Welcome to Study Time, a televised home learning program produced by Rwanda Education Board.
Our dear students of Senior 1, once again, I'm here to welcome you, your chemistry teacher, as usual. Today, we'll be looking at unit number 10 again, because you remember we had looked at this unit about the chemical equations, and our lesson of today will be emphasizing on balancing the chemical equations or the chemical reactions. This is our lesson of today, balancing chemical equations or chemical reactions. You remember in the previous lesson, we are looking at how we can form these chemical reactions, looking at the symbols of the substances and how we combine the symbols to make the formula, and then from the formula, we can be able to make the equations, or we remember we talked about the word equations, and then we talked about the chemical equations using symbols. So this time around, once again, we'll be looking at the chemical reactions, but emphasizing on balancing chemical reactions. So let's move on. So when you look at the reaction on the screen, let's look at the screen. That is one example of the chemical reaction. Now on both sides, you need to look at, we are just going to go through slowly together and read those questions. How many sodium atoms are there on the right-hand side of the equation? So the right-hand side, usually an equation has two sides. You have reactants, when we say reactants, and then you have products. I'm sure you still remember this. This is one side of the reaction, and this is another side of the reaction. So what about the left-hand side? Looking at the reaction there, look at how many sodium atoms are on the right-hand side and how many are on the left-hand side. I'm sure you can tell that on the right-hand side, you can see two sodium atoms. Two sodium atoms. This is what I'm talking about. So you have sulfuric acid reacting with sodium hydroxide. This is giving sodium sulfate and water. This is the reaction that I'm talking about. If you look at this reaction, let's come back to the blackboard again. So when you look at this reaction, you find these are two sodium atoms. And this side, we have only one sodium atom. So these sodium atoms are not balancing in this reaction. And yet these are the right symbols. How many hydrogen atoms are there? So look at the hydrogen atoms. We have this and we have that. But this time we have these two. So the hydrogens this side are 3, but this side there are 2. And when we are talking about the balancing, the number of atoms on either side, that is my left now here and my right, must be equal. Compare the number of sulfur and hydrogen atoms on both sides. When you look at the sulfur, we are very lucky. Sulfur is one here and another sulfur is there. So sulfur is balancing. Sulfur is balancing. Are the atoms on the right-hand side left equal to the, that is the question that we are asking even today. Are they balancing? We have 4 oxygen and we have only 1 here. So that means this side there are 5. But this side, how many are they? They are also 4, they are 5, they are balancing. But are all atoms balancing? That is the question that we are going to answer today. And when you look at the equation, it is very clear that the reaction is not balancing. I think we have already talked about it. So that is our purpose of today. We have to make sure that the reactions are balancing. And balancing is in our daily activities, in our homes, in our villages, is compared to the distribution of resources. The distribution of the resources can be either at school, the resources can be either at home, and the services as well. So we are supposed to get equal services wherever we go, irrespective of either the race, the color, the size, or whatever we are supposed. So that is how we compare this balancing of these reactions in our daily life activities or in our families and in our communities. So it is very important to note. So balancing the chemical reaction, for every chemical reaction that occurs, all chemical reactions must observe the law of conservation of matter. The law of conservation of matter. Let's go to the screen and see what the law of conservation of matter talks about. The total mass of the reactants in a chemical reaction is equal to the total mass of the products. That is very important. The total mass of the reactants in a chemical equation or in a chemical reaction is equal to the total mass of the products. Atoms are neither created and can be destroyed. So the atoms that you start on one side of the reaction must be the same atoms that you have on the other side of the reaction. There is only rearrangement in the atoms when a chemical reaction takes place. That is very important. And when we are balancing these chemical reactions, let's go back to the blackboard again. When we are balancing the chemical reactions, we are just going to use inspection method. There are other methods that we can use. There is a algebraic method that involves simple calculation. But this time, let us first use the inspection method. When we look at this, these are two sodium atoms. When we are balancing, we are not going to write the figures. We need to write the figures in front of the formula. So to make this sodium 2, these are two atoms. So we have to write them here, not here. So they are not written. So these are coefficients that we are writing. So when we write 2, so the only places that we can write is only this, is only here, it is only here, and even here. That is where we are only supposed to write, and we can use whole numbers, or we can use even fractions if need be, as we are going to see. So when we look at this reaction, by just mere putting the 2 here, balances the reaction. The reaction becomes balanced. The 2 hydrogen plus this 2, because this 2 is for the whole of this, so this 2 is for even hydrogen, it means that there are 4. We have 2 here, and these 2 here, that is 4. And then when we come to this, how many are they? Are they 4? They are only 2. How do we make them 4? So we need to write a 2 there. So when we write a 2, the hydrogens will be balancing. That is how we are supposed to be balancing these reactions. But we need to go through the rules. So these values that we write here that I've mentioned, they are called stoichiometric ratios. Stoichiometric ratios. So these are the values that we are supposed to write. They can be either whole numbers or they can be fractions. There are certain rules that we follow when we are doing this. For a chemical reaction, we'll first have to write a word equation to show the reactants and the products. For example, if I have magnesium, we start with the word equation, magnesium plus oxygen. This will give magnesium oxide. Magnesium oxide. So after writing the word equation, what will be the next? Write the correct symbol and formula to represent what you have written in words. Magnesium is represented by, I'm sure you still remember this, magnesium. It is capital M and small g. Then you have oxygen, which is O2, and then you have magnesium oxide, which is in this form. So those are the symbols to represent what these words. If the numbers are not the same, then we just look at the numbers now. Those are the atoms that we need to look at. When we look at this, magnesium here is 1. I'm sure you can see that magnesium is 1. And when you come to this side, even magnesium is 1. So magnesium is balancing. If they are not balancing, then we need to balance them, make them equal, to make sure it satisfies the law of conservation of matter. The mass of the reactants is equal to the mass of the products. And there is no atom that has to be destroyed. So the atoms that appear on that side must be the atoms that will be appearing on the right-hand side. So there will only be rearrangement of these atoms. So the oxygen atoms, there are 2. But the oxygen here is 1. Are we going to write 2 here like this? No, we are not going to write 2 here. We said we can't balance by writing the 2 here. So we have only places where we can write here, here, and there. Those are the front of the formula. Now, how do we make this magnesium, this oxygen 2? We are going to write a 2 over here. So when we write a 2, oxygen will be balancing. But there is another problem that we have created. When we have balanced oxygen, but we have created another problem. Can you identify the problem? Can you see the problem that we have caused in balancing the oxygen? Because the oxygens are now balancing 2 and 2. So what is the problem have we caused? The problem that we have caused is that magnesium now becomes 2, whereas magnesium is 1 here. So what do? There is nothing special that we are going to do. Just make these 2 magnesium, and then the reaction becomes balanced. Now, after balancing those reactions, we need to give the symbols of these substances. We need to give them symbols. How do they exist? What are we talking about, the symbols? The states under which these substances exist. Is it a gas? Is it a solid? Is it a liquid? Is it aqueous? When it is dissolved in water. Substances which dissolve when they are dissolved in water are said to be aqueous solutions. So is it an aqueous? Oxygen exists in nature in the atmosphere. I'm just talking because I am getting enough oxygen here that can be used to burn the food that I've eaten to produce the energy that I can be able to speak to you. So the oxygen here exists as a gas. So we just put a small g if it is a gas as a subscript. So the magnesium is a metal. Metals exist as solids at room temperature. Just look around and see the metals around where you're seated. You'll see that they are solids, with the exception of only one metal, which is mercury. Mercury exists as a liquid. It is the only metal that exists as a liquid. Other metals exist as solids. So we need to put a solid over here in brackets, small s in brackets like that. What is remaining? We need to look at this magnesium oxide. The oxides of the metals or the oxides of the metals exist as solids. So we put a solid over there. Then we need to counter check again. Magnesium, there are two magnesium on that side. Oxygen, there are 2. Oxygen, there are 2. So we give ourselves a tick. The equation is balanced. The equation is balanced. That is what we are just going to do. And make sure when we are balancing these reactions, we need to make sure that we use the lowest values, the lowest possible values. Now, let's give another example. For instance, you have aluminium. Aluminium is a metal that is used to make these aluminium sheets, a lot cutlery, the spoons and whatever. Aluminium plus oxygen gives aluminium chloride, aluminium oxide. Aluminium oxide, like this. So what we need, we have aluminium as a metal. So we are going to represent this as in the symbol form, then plus the oxygen, which is a gas, and then this gives aluminium oxide. Aluminium oxide, aluminium has a valence of 3. Write symbols. You need to remember what we were talking about, what we talked about in the previous lesson. So this is 2, and this is 3. Now, you have represented the reaction from word to chemical. After that, you need to balance. Look at the atoms this side. Aluminium, there are 2. Here, aluminium, there are 1. Oxygen here, there are 3. So we are just going to make sure that we make aluminium 2. If we have aluminium 2, aluminium will be balancing. That's correct. I think you can see that. Now, when we come to the oxygens here are 3. How are we going to make them 3 here? How are we going to make them? Because we have 2 already. Are we going to put another oxygen here? No. We are not going to put another oxygen. We can't add another oxygen. So we're just going to look for a value. If we multiply it by this, it means if we multiply, for example, this oxygen by 3, if we put a 3 here, the oxygens will become 6. What about here? The oxygens are 3. So if we put 2 here, the oxygens will be 6. Now that means we have balanced the oxygen. But is aluminium balanced now? No. Aluminium is not balanced, no longer balanced. So we need to change the aluminium now. So this one has to change because the aluminium here has, how many are they? 2 times 2, they are 4. So the aluminium is 4. So now we need to change and write a 4 here. Now, after that, we can now check. Before we check, we need to look to put the symbols that represent the states of these substances. Now, this is aluminium. Aluminium is a metal, so it will be a solid. Oxygen is a gas, as we have mentioned below, and the oxide this is a solid. The oxides of metals are solids. Then you counter-check again. Check the number of atoms. You have to make sure you make those checks from time to time to make sure that your equation is balancing. These are 4. These are 4. These are 3 times 2. Those are 6. 2 times 3. Those are 6. So you need to make sure that the reactions are balancing. Let me give other simple example. Hydrogen gas combine with oxygen to give water. So water is made up of oxygen and hydrogen. And this is hydrogen, which is represented by hydrogen gas is H2, plus the oxygen gas, which is also 2, and this one is water. That is the formula for water. Now, we need to balance. How do we balance this? This hydrogen is 2, hydrogen is 2. So hydrogen is balancing. Do we need to balance it? No. If it is balancing, then we don't need to balancing. Now oxygens, there are 2, but here it is 1. So what do? Simple, just write 2 here in front. Not here, please. Here, that is the front. So when we write 2, this 2 is for the oxygen and hydrogen. But we have caused another problem when we are balancing the 2 for when we are balancing hydrogen. Do you see what we have caused on the equation? Because now the hydrogen has become 4. But what about this side? Are they still 4? No, they are no longer 4. So this, we need to balance them and make them 4. So this is the equation now, or our chemical reaction, which is balanced. So hydrogen is a gas, so we put it small g in brackets. Oxygen is a gas, we also put small g in brackets, whereas water is a liquid. I think everybody knows that water exists as a liquid under normal temperatures. When you put it in a fridge, of course, you change the temperatures, and then it cools down and becomes solid. When it freezes, it becomes a solid. If you heat it and boil it boils, then it can change into the vapor. So, but this, we are just talking about water under ordinary conditions. Can we have another example? Yes, let's have another example. We have sodium plus oxygen. This gives sodium oxide. Sodium oxide. Can you write with me now? Just sodium is represented by which letter? I'm sure you still remember that sodium is represented by Na, not S, because sometimes we also forget and represent it as SO. No, it is not SO, because the name of sodium is derived from the Latin name, which is natrium. So that is why we have Na, because some of these ones, the names are derived from Latin and others from the English names. So oxygen, and then we have sodium oxide. Sodium oxide is written like this because oxygen has valence of 2 and this has 1, so they will have to interchange. Now we're just going to balance this. So we said this is oxygen here. No, this is 2 to make the sodium balance. Now we have balanced sodium, remember, but are other atoms balancing? Let's look at oxygen. The oxygen here is 2, but here it is 1. So we have to make it 2. But when we put 2, another problem arises again. The 2 makes sodium 4 to balance the oxygen. That means this 2 is not correct. So we are going to change and make it 4. The equation will be balanced. What is next? The symbols. And what is next after symbols? Counter check and check to see whether the reaction satisfies the law of conservation of matter. Let me give another example. We have aluminium plus chlorine. Plus chlorine, this gives aluminium chloride. It gives aluminium chloride. Aluminium chloride. The symbols that represent all this, we have aluminium, we have chlorine, and we have aluminium chloride with 3. So chlorine is a diatomic molecule like oxygen. So we'll have 2 for chlorine and this aluminium. So what are we going to do now? Remember, the equation must have the right and left, so we need to put this. So what happens now? Aluminium and these ones are balancing. So we're just going to look for a factor that will have to make these the chlorine atoms balance. And which factor is this? If I multiply by 2, This will become 6. And then here I multiply by 3. So that means we'll have a balanced reaction. Put the states. Chlorides are solids, and aluminium. Aluminium is aluminium balancing now because aluminium is 2. So we need a 2 here as well. So that is how we balance. That's how we try to balance the reactions. When we're balancing the reactions, that is what we usually do. So before we look at the homework, I just want us to just do only one example. This is the last one. So we have magnesium plus nitrogen. This gives magnesium nitride. Magnesium nitride. So what are the symbols that represent this? You have magnesium over here plus the nitrogen. The nitrogen is like this, plus magnesium nitride. This is 3 and this is 2. So we need to balance that one as quickly as possible. Magnesium is 1, the magnesium is 3 here. So just make magnesium 3, as simple as that. Now after making the magnesium 3, how many nitrogen atoms? There are 2. How many nitrogen atoms here? There are also 2. So this is a gas, this is a solid, this is a solid. So you have balanced the reaction. That is very simple. So let's go to the homework. Dear students, that is C5H12, that is number 1, plus oxygen giving carbon dioxide and water. You are supposed to balance these reactions. Balance these reactions. Balance these reactions. Make the atoms equal on one side and the other side. The right-hand side and the left-hand side. Giving carbon dioxide and water, zinc plus hydrogen, giving zinc chloride and hydrogen, calcium hydroxide with phosphoric acid, calcium phosphate, and water. Make sure the atoms on either side are balanced.